John, what are we going to learn in this video?
Today, Ramesh, we're going to learn about bit-specific addressing. Bit-specific addressing is a flexible way to access the data pins. Okay? And we're going to use it for input and output. So bit-specific addressing is only used for the data register. Okay? So that's what it is. Okay? Next, let's talk about why we use it. Okay? Why do we use bit-specific addressing? And to me, there are three reasons for using bit-specific addressing. The first is I think it makes the code really clear. Okay? Because we're going to use an abstractive method, that means that we can give names to the I/O pins. It'll make our code really, really clear.
So for example, if we have lights in our project, we can call them lights rather than call them data GPIO data port.
Yeah, lights, switches,
buttons, alarm.
So we can use a name for the I/O pin. That'll make our code really clear. The second important reason is to do about change. So engineering often involves changing. And so if I've used PA5 for the light and I want to change it to PB4, that'll be a fairly easy change to make once I use bit-specific addressing. But to me, the most important reason to use bit-specific addressing in this class is it is inherently friendly. That means when I access PA5 using bit-specific addressing, it will automatically only change PA5 and leave the other 7 bits alone. So let's talk about next, how do we make such a wonderful thing happen? There are two aspects of bit-specific addressing. The first is the base address, and that is a mapping of the port number, the port letter, to the address for those GPIOs. And these are the port base addresses for the ports A, B, C, D, E, and F. These are the addresses. Okay? And the second aspect is the offset, and it's in the offset that we can specify either one of the pins, 2 of the pins, 3 of the pins, or all of the pins. Okay? So we're going to have an offset. And so when I want to access bit 7, I'm going to add the offset of 0x200. And bit 6 is going to be 0x100. And bit 5, 0x080. 4 is 0x040. 3 is 0x20. Bit 2 is 0x10. Bit 1 is 0x008. And bit 0 is 0x004. Just to remind you of what we've been doing all along, let's first look at what happens if I wanted to access all 8 of the pins of one of the ports. In other words, I would add up all of these offsets. And if you were to do that, if you were to add all of these, you would see that they would sum to 0x3FC. And then when we add the offset to the base address, for instance in port A, we would see that this is 0x4004 3FC. And this is actually the port A address we've been using all along. So all along we've been actually using bit-specific addressing, but accessing all the pins. So next what I want to do is to show you how to access just one of the pins. So let's do an example where I want to access just port A, bit 5. And we're going to do this with the two parts. The base address is 0x4000, 4000, and the offset for bit 5 is simply 80. And so when I add these together, the address for port A, bit 5, is going to be 4000, 4080. And if I make a definition, with that address, right? So our port addresses, we go pound define, and then I'm going to give it a name. In this case, I'm going to just call it PA5. I could call it anything I want. And then I use this magical C code to make a port, volatile, unsigned, long, star, parenthesis, I give it this address, 0x4004, 080, parenthesis, parenthesis. Okay? If I define this port, now what I have is magic. And so if I use this in my C code, I can write code like this, PA5 equals 0. And what that will do is it will just clear PA5 in a very friendly way.
So notice that you don't have to do any masking of the sort. Writing a 0 to PA5 will not touch any of the other bits, because this address is it gives you access only to bit 5. You cannot change any other bits even if you want to.
Okay. If I wanted to set PA5, this is where it's a little bit harder. I have to write a 1 into the bit 5 location, which is a 20, and that will set bit 5. Again, in a very friendly way.
John, can we look at a combination of bits?
Yeah, we can make it harder. Okay? Let's make it harder. Let's say I have a system where PB6 means something, like that's peanut butter. And let's say PB4 is my jelly. All right, so I got two things that together mean something. And what I want to do is to create one object called PB and J, which is the combination of the peanut butter and the jelly, which is going to be a combination of bit 6 and bit 4 of port B. So we'll do the same thing we did for PA5, and that is we'll start with the base address. But this is port B, so we're going to use the base address for port B. That's 4,000, 5,000. That's the base address. And now I need the offset for both bit 6 and bit 4. And so the offset for bit 6 is 100, and the offset for bit 4 is 40. And so I'm going to add them up. And so the address of bits 6 and 4 together is going to be the address 4000, 5140. And so just like I did for the PB5, well, let's make a definition. And you can see it's in this definition that I've created the abstraction, right? I'm going to call it PB and J, and that is peanut butter and jelly. And we'll do the C magic just like I did before, but in this case I'm going to use the address 4,514. Okay? And now when I access PB and J, I can write or read the individual bits of these two. But in order to see how to do it, let's make a table. And so if I want to set the PB and the J separately, okay, if I want a 0, 0, what I'm going to write is I'm going to write PBJ equals 0. And if I want to set just the peanut butter without the jelly, okay, I'm going to write to PBJ and set bit 6. And we're going to do that by writing a 40. Okay? If I write a 40, what this will do is clear bit 4 and set bit 6, and the other 6 bits of port B are going to be unaffected. If I want just jelly on my sandwich, I'm going to write code 0x10. And that will clear bit 6 and set bit 4. And of course, if I like my sandwiches with both peanut butter and jelly, I am going to write a 50. Okay? And this will set both bits 4 and 6. So in summary, what we've seen is bit-specific addressing is flexible. It allows us to access individual bits. And secondly, it is a very friendly way to use our devices. So in this class, using bit-specific addressing is an optional method, and you'll see it in some of our examples.